and then I will just talk you through about how this case got compromised, and then how it got affected, and also talk you through some popular supply chain attacks, and then just briefly talk about what you can learn from all those stories. And before all those things, just a code of ethics: don't do bad things, because hackers would use this case, like this case is happening a lot in the wild. So don't do bad things. If you got caught, hope you didn't got caught in the jail. So don't do bad things. So first, just talk about what is cyber chain attacks. A traditional cyber chain consists of 5 stages. So a supplier supplying some things into the manufacturer, and then the manufacturer make that thing, and distributor will just distribute those things to the retailer, and then retailer give those things to the customers. And inside software supply chain is similar. Like there are some source, like some source code, and then it's with those codes, those engineers will make those codes into a product, and then deploy it through the network. And then with some repertory like GitHub, you can download those softwares from them. So this is a software supply chain. And what software supply chain attacks means, the attackers just try to make the app to be a malware, and just find some way to make some people to download that malware, like by modifying the source code and doing different kinds of things. But you may ask how the attacker can modify those source code. Those source codes should be controlled by us, like the engineers. So this is how cyber chain attacks could be. Like there is 4 different things, like the software update, containments, software libraries, contamination, and firmware contamination, and waterhole attacks. I will not talk you through all those things, but in this case, this is a kind of software update contamination. So, which means the attacker changed the source code into some malware, and then our users download it, and then we will got the malware. So, how the exact Unity got found to be compromised? Before I talk about this, just briefly introduce what this package is. Exact Unities is used for compressing and decompressing 2 different file formats called .exec and .lzma. And what's special to this file format is it got a really higher compression ratio than some alternatives like gzip and bzip2. So many networks will be using that to send their packages. And one special thing, number of Linux distribution like Ubuntu, Debian, and also Mac OS is using exec for compressing their software packages. And then some Linux distribution will change their system D to just patch it in order to make them to have the system D notification. So the OpenSSH, this package inside those Linux distribution will be having dependency on the exec library. So this is just a screenshot of my Mac OS. So basically everyone, if you are using Linux distribution or Mac OS, you got this package. And this was found, the backdoor was found in version 5.6.0 and 5.6.1, and it is presented in the development version of the major distribution. And when the SSH is run as a service by the system MD. So I previously mentioned because the OpenSSH uses this one, and then is the SSH server also explode into the internet. The attackers then can do some remote code executions by bypassing the open source OpenSSH authentication. So this is how the backdoor, what this backdoors used, I would say, and because of its popularity, it got the highest CVE base score. So if you don't know what is CVE, you can just treat it like a library of vulnerabilities, and 10 is the highest scores in the CVE library. So it just got a really high score, which means it is really critical vulnerability. So after introduce all those things, let me talk about how it got found. So one day, a Microsoft engineer, just when he is doing some micro benchmarking. So you don't know, maybe you don't know what's micro benchmarking. Basically, you just monitor the computer's components, but in a really micro scales. So like in a milliseconds, and just monitoring those things. And when it might monitor the CPU, it finds out that this SSHD uses up a lot of CPU time because of this library, and it's just a little bit weird. So you will see it got 0.6 seconds longer than usual, but like as a usual person, you won't see this as malicious. But because this is an expert in doing this kind of things, so it just find out this may cause some problems, or this contains some malwares inside, and the software engineers start digging into that package and found out that this is a malware. And you could say that this is a really lucky case, but yeah, but in the wild, it got a lot of different kinds of similar things in the wild, and this one is just a lucky case that a software engineer found out that. So this is the whole background of this backdoor, and so now change into the attacker side. How this case got infected. So the stories need to go back to 2021. There is a guy opened a new GitHub account called JTan, and this is just a normal GitHub user. But back in 2021, these users do some normal developer things, like create some pull requests and making some changes, just contributing those package. And in this stage, it is contributing a package called libarchive. And this one is basically not relevant to this case, but I just want to show you that back in 2021, he just tried to contribute to the open source software community. And what it wants to do is basically gain some trust from the community. And one weird thing is, one of the pull requests is changed it one thing. Like this one is basically adding a error test, but if you did into those codes, it changed it a function called save printf into only printf. So you can just treat it. It uses another unsafe function, but this didn't have any proof that this is used to create another backdoor. But if you are smart enough, this is a kind of weird thing. Like a normal person will not change a repository with some unsafe code. So, but this is another package. It's not the case that we are talking about today. So, 2021, this guy doing those things, and he starts to contribute to the case. What the case we want to talk about today is the exact development. How he contribute? First, he just sent an email. J10 just sent the email to the developer, just contributes some of those codes and like adding a .editor config file. But in this stage, it contributes a lot. So in the left-hand side, you see a lot of contribution, but all of those contribution is harmless. What he want to do is basically gain the trust from the developer, because he want to modify those codes. He need the control of the repository, so he want to try to gain the trust. So time flies to 2022. One day, J10 just keep sending those contribution emails to the developer. So this is just a normal thing, just sending some requests. But if you see that, there are some weird replies. Suddenly, a guy called Jagakuma, should be pronounced like that, and he just said that, I didn't test your code, but if they work, it's just need some minor adjustment. Your effort is good, but because it's a really slow release schedules, it will be unfortunate, be years until the community actually get this quality of life features, which means it just try to attack the maintainers, just that you are doing slow, you are doing bad. So try to give some pressure to the maintainer. And J10 just came back and replies that the contributors is just a hobbyist like us. It's just a hobbyist. So we didn't got much time to develop those softwares. And the guy just continued to give some pressures to the maintainer. Like, I have been spending years on this mailing list, and the last release already 7 years ago, and no reason that anything's come out soon. And then keep pressuring 1 month later, over 1 month, and no closer to being merged, no surprise. So just giving more and more pressure to the maintainers that you are really slow. Give the permission to another guy, and he will help you to maintain the repository. So you may ask, who is this guy? Okay, this guy is J10 himself. So he is using another user, just try to pretend to be another user to attack and use and reply by myself to gain the trust from the maintainer. And so Jagger also said that, why can't you commit this yourself? So you see, and what he really want to do is just gain the permission of the repository. And another guy came out called Dennis. So you can guess this is also J10. So he said that XAT still maintained. I've got a question here a week ago, but haven't heard it back. And then this time, the original maintainer, Colin, start to reply. The development is definitely not very active, and J10 have held me off list with exact unities and may have a bigger role in the future. Oh, the maintainer said J10 have a bigger role in the future. So he got something. Yes.
How do we
um, some of those people found that those emails is sent from similar IP region, like as yeah, should be, because from those I would say, like, from those words and also from those IP address, we can guess that all those accounts is sent from himself.
So it suggests that there are smarter people that have done this and have been successful, and we're not knowledge.
Yeah. So in the wild, it may still have some similar cases in the wild. So you may track some of those things in the wild. And so, continue with this case. The colon just said that it may have a bigger role, and then this guy came out and then keep adding more pressure, said that the current maintainers lose interest and didn't care to maintain anymore. And the colon just replied, again, J10 will have a bigger role in the future, it will see. And then it just giving more and more pressure by saying, why you don't change the maintainer? Why you delay those repos? And Dennis just came out again and just said that why you not passing the maintainership to someone that is better than you? And at the end, so Colin just said that J10s have been helping me a lot, and in the future or currently, it's just trying to transfer the ownership to J10. So J10 achieved his purpose because he wants to gain the ownership of those Ripple. Then he can inject some malicious code into this Ripple. So after it's taking over the exact Unity Ripple, so at first J10 can be authorized, but it didn't able to commit by himself. But in the end of 2022, it got the permission to merge by himself. So which means he already got the whole permission to do anything to this Ripple. But in this case, it didn't inject any malicious code into the library. So just keeping some normal commissions. And some weird thing happens. One of the weird things that J10 do is changing the OS fuzz. This case is also, yeah, one of the weird things is changing the OS fuzz into his own email address. So OSS fuzz is just a library for you to discover some vulnerabilities. You can scan your software, and it just changed the primary contact, which means now I am the owner. And he tried to prepare the attack. First one is this file. Someone just said that just use a committed thing, try to push something into the Ripple and changing a function called changing a file called ifunction. And this is a messy code, but ifunction is a mechanism that allows the glibc to indirect some function calls. So you can just treat it like a hook or a trigger. Like when the OpenSSH want to authenticate, this function can be used to redirect to another function. So you can bypass the OpenSSH authentication. So this is the first thing that J10 changed to make sure that he can able to redirect the authentication routes. So you may ask again, who this guy? And we guess that this is also J10. So he do all the things by himself. And so another weird things, as I mentioned, OSS First is a tool to scan some vulnerabilities, and J10 tried to disable this eye function scanning. So he want to hide this weird things from those people when they are scanning with this tool. So this is one of the attack he prepared. And the second thing is this file called build to host.m4. What this weird thing is, because it is included in .git ignore, which means those files will be excluded in the source code. But when those developers build their .tar file, so what we usually download, it includes this file inside. And later I will tell you what this file is used. So after doing all those things, J10 ready to attack. So he added two field of those test files, and which includes two files. One is called bad corrupt lcma.exe, and another one is just the one below. And all those test files is normally used to verify the exe is running properly. But this two highlighted test file contains some obfuscated binary backdoor. And another day is just send the release to the wild, just make the stable one. And do you remember there is a file called build to host.m4? This file is used to deobfuscate the file, that the weird test file that I mentioned before. So let me do some coding things. Okay, this one is part of the source code of the build to host.m4. It is a little bit messy, but basically it's just obfuscates one line of shellcode into a really long thing. So first, it tries to grab this one. This one you can see is just a test file that I mentioned before, but it's used this whole line of shellcode to only grab this file, and then tries to deobfuscate the file, and then get the exact, and then you can see with all those lines, it can be only converted. It can be used to convert into one single line of shellcode. So this line of code. And furthermore, after deobfuscating the test file, it will become this line of code. And also, the most important thing is the middle shellcode. And let me see, just skipping those parts. After all this obfuscation, you will got the final malware. And the malware function really complicatedly, so I will not mention in this talk. You can basically go to look at all those papers if you like to, but you will need a lot of binary exploitation knowledge in order to understand how it works. So you can basically look at all those online. So another attack is just try to add a dot here. What this dot is used at is basically try to bypass the landlog checking. So adding one dot will make the whole checking not usable. And so Injurious just find out this, and then the maintainers try to regain the maintainership, and then try to remove all those malwares from the repo. And this is how the case end. So in the wild, there's a lot of different popular cyberchain attacks, like the SolarWind case, because time is running out, I'll just skip all of those. Like some SolarWind case, and Apple Xcode Ghost, and also one called Cassia vs ransomware attacks. It uses a similar method, like just try to change the cyber chain, try to manipulate the source code, and let those people to download some malwares. So what we can learn from these stories. First, we will got some risk when using some third-party softwares. So just check the supplier's reputation. Also, if you found some malicious, suspicious behavior, like your computers are running slowly recently, it may be caused by some new software or because you install some weird updates. But there's a benefit of using open source. Because this is open source, some crazy guys, like the Andrews one, it will uncover those security issues more quickly and easily comparing to some closed source software. And another architecture we can use is called Zero Trust Architecture. You can search it online later. This one basically, you trust nothing, including the software itself. You need to gain their trustworthiness before gaining the access. Okay, this one is a architecture that some companies will use, and it helps to prevent this kinds of attacks. So these are all those things we can learn from this, and this is how the stories goes. So thank you for your listening. Just a little bit rush, and this is the PowerPoint. If you like to get it, just this one is the QR code. And thanks for your listening. If you like to talk to me, I will be staying here for a while. So thank you all guys for listening.